This is the latest version of the DCVF tool for the CoolSaver program. If you want to check and see which version you're running, here's the version number. You just click help and it'll take you there. When you open up the software, you'll be on the main menu, and this is where your tune-ups are listed. And if you want to look at uploaded tune-ups, you click this box right here and it'll show you any tune-ups that have been uploaded. So if you notice, I click this, we have no tune-ups ready to upload. Most of you will be doing modeled tune-ups, so you'll click this button when you get ready to do a tune-up or enter a tune-up. If you need to set up your contractor information, you click this contractor tab. You go through here. This contractor ID is system supplied, so you don't change that. You put in your company name, your telephone, the contact person's email, your altitude for determining some of the data in the software for refrigerant pressures. Click your utility. So if we were doing AEP Texas, we would click this. If you want to add a technician, you would come in here with under technician name and put in new tech, his name. You tab through it, so you click tab, that gets rid of the green. The new tech's telephone number. Tab again. If you page down, let's see, or tab down, it will get you to the rest of the information. You put in the technician's qualification number, so that might be something like this. Again, tab and then save. So we have a new tech set up, and it takes us back to our main menu. And if we want to edit the contractor data, you can do that here or this tab. Here's your main file. This is an M&V tune-up. Modeled is what we're going to be doing most of the time. So let's click a model tune-up and put in a new tune-up. So get your data from your field sheet that's filled out by the technician. This is taking a second to load. So if we pick the technician that did the tune-up, you can set up several technicians in the software. So let's pick new tech. You're going to click this little calendar here, and it's going to pick the date that the tune-up was done. Let's say it was done last Friday on the 5th. So we got the 5th in here. Let's say it's an AEP Texas, which is South Texas. This invoice number is for your use. You have to put something in to get rid of the green, or you can't move on to the next tab. So if it's residential or commercial, you'll notice when I did this drop down arrow, this slider is at the bottom, so I have to go up to pick single family. And of course that's residential, already pre-selected for you as single family. The zone, if it's the main system, you're going to click that. If it's an upstairs system or downstairs or bonus room, you would select one of those. The air handler location, if we have to do an inspection or the state has to do a follow-up quality control inspection, then this helps them find it. So let's say it's in a closet. And then this, when you put your sticker on the unit, put some kind of ID on there. As an example, if it's a school and it's a rooftop unit, you might put RTU number 23. And then again, it's easy, much easier for us to find that unit if we're doing a follow-up inspection. So I'm going to tab down to the next thing. If you have already put a customer in, then you can use this drop down and select the customer, and it will populate most of these green customer tabs for you. I'll go ahead and pick one. So let's just click test ID, and see, we were going to do a residential, so let's find a residential here. So it filled this out, billing address, Customer email, get that for your own use if you can. Telephone number, we need that. If the billing address is the same as the physical address, then you put that in there. You can scroll down to the bottom here. You want to pick your county, so if it's let's say it's Hidalgo County. So pick Hidalgo County. The zip code has to agree with the county you select or it won't let you go further. So this zip code is in Gregg County, I believe. There it is, Gregg County. So that allowed me to do that. This is where you put in your Easy ID. You can't get paid without an Easy ID. Your Easy ID is a 16-digit number. The first 8 digits indicate which utility it is, and the last 8 digits indicate the customer. So I'm going to click next, and if you notice, modeled popped up. So now we go to the data that the technician collected on site. Most often they'll be using airflow method 1, which means they got a grill length and width. So let's say this is 12 by 36, and he measured an airspeed of 400 feet per minute. That's going to come off the block in your paper form. So you tab out of that. We got rid of all the green. If they don't have the grill in there, then they might have used airflow method 2, which is static pressure. So you would put in the return static pressure, the supply static pressure, and it'll ask you for a CFM, and you put that in. But see, it calculated 1200 CFM, so that's your calculated CFM. So let's scroll on down, and you'll look on the unit, and it should have circled whether it's a split AC or a packaged, which would be a rooftop AC or heat pump. So let's say this is just a residential split AC. The compressor type should be circled, either scroll or reciprocating. The refrigerant type should be circled, and the manufacturer should be indicated. So let's call this a Carrier. And then the metering device is either a fixed orifice or a TXV typically. So let's say this is a fixed orifice. Then the condenser model number is going to indicate what size unit is. So let's say this is a TTR 036. I click my tab, that's going to take me over to my serial number, and we have to have a serial number that indicates, that's the way we track on nominal tonnage. This 036 indicates it's a 3 ton, which should be on the form that the technician has filled out. So now we're going down, and on the unit it's going to tell you what the nominal charge for that unit is. If it's not on here, it's typically 2 pounds per ton. So I could put this in as 6 pounds or and 0 ounces, or I could put it in as all ounces. 0 pounds, and 6 times 16 would be the number of total ounces. So if the technician adjusted the refrigerant, and normally they have a remove, even if they didn't adjust it, by testing the unit they've removed a little bit of refrigerant. So I'm going to put in here that he removed 1 ounce tab, so that's minus 1%. This indicates the outdoor ambient temperature. It's got to be above 75 degrees when they're doing the test, or it's going to ask for wet bulb. So if I put 71 degrees in here and hit tab, then it's going to ask me for a wet bulb. So it's got to be above 55. So let's say it's 60 degrees, and it's okay. So and this yellow indicates caution that it's really close to the minimum 70 degree temperature. Would you like to calculate EER? If you want to, you can click this and it's going to ask you for some electrical information, but that's not mandatory. Return air wet bulb for target superheat. The indoor return air wet bulb is necessary in order to calculate the target superheat. So let's call the indoor return wet bulb 65. Okay, I've tabbed through that. So now I'm down to my refrigerant pressures, and you'll see those. There are 8 inputs that he reads from his refrigerant analyzer. So we're going to put these in. And again, these are just arbitrary numbers that I'm just plugging in here. Okay, so the scroll down. I want to go over this a minute with you. This target superheat is what was calculated by the software. So the technician is going to calculate his target superheat using a different system on the job. But this superheat number needs to be plus or minus 3 degrees of this target. So he's reading off his gauges a superheat of 20. The target superheat is 21, so that's acceptable. It's plus or minus 3 degrees. So you'll see right here. If it was a TXV, then he would charge it by subcooling, and the subcooling target would pop up over here, and it's going to say it's 10 degrees plus or minus 3 degrees. So if it was a subcooling target, then 7 to 13 would be acceptable. Okay. One thing you want to check is this liquid line temperature must always be lower than this outside air temperature that we got up here earlier. Okay, will always be warmer than. Okay, so then the last measurement he's going to take is his return air dry bulb and wet bulb temperatures. They are on the lower right hand corner of the form. So let's say we have a 72 degree return air dry bulb, and let's say we have a 62 degree wet bulb, and our supply air is 55 degrees and our supply air wet bulb is 52 degrees. If you note now, if I put 56 degrees in here, you're going to see a red and yellow. The wet bulb is always lower than the dry bulb. So anytime you see a red border around here, or yellow means caution, red means it's not acceptable. So I put the correct one in there, and then when I push this next button, these capacities are going to pop up and populate here, and that's going to give us our test results. So for this 3-ton system, let's see what it gives us. It's going to tell us we're doing about 2 tons of sensible, about a ton of latent, so we're doing 30,000 BTUs. A 3-ton system would be 36,000 BTUs. So this one's actually producing about a half ton less than its rated capacity. So that's your results. So now since we filled all this out, our corrective measures pop up. And so what he's done is he's cleaned the condenser coil. That's mandatory. He's cleaned, or the blower assembly is acceptable. He's cleaned, or the evaporator is acceptably clean. He's cleaned or verified that it has a clean filter. He's checked whether this is a circle on the form. He's checked whether the system's well maintained or the duct system's well maintained, and the useful life of this system, the tech has estimated at 6 years, the remaining useful life. Okay, so that completes the tune-up. You have a savings form that you can print and mail to the customer, or you can email it to the customer if they've given you their email, and it just gives them some basic information on the system and some savings information. So this particular customer, with the data we put in, is going to save, we improved it 23%, the efficiency is 27%. If he's going to save 795 kWh, so that's about $79. It's 10 cents a kWh. Call if you have any questions.